Now for part B of this problem, we need to look for the expected value of x and the expected value of x squared. Now for the expected value of x, this is actually going to be equal to 0. And the reason is because the whole setup is going to be symmetric, your wave function is going to be symmetric, and so your particle is equally likely going to show up on the left-hand side of the x-axis as it is going to show up on the right-hand side of the x-axis. So everything is symmetric. So in the end, the expected value is just at the very center at x is equal to 0. So that's why the expected value of x is equal to 0. Another way to argue that the expected value of x is equal to 0 is that you can take a look at the expression for x. You can express it in terms of r and theta and phi. And then if you're looking for the expected value of x, you're simply just plugging this term into the integral, and then you will integrate it out, and then you will find your expected value. And then you can see that you're going to integrate a cosine phi. And then in the end, you're going to integrate this cosine phi from 0 to 2 pi. And then when you do that, you're going to get a 0. So this would be a more quantitative argument. And you can see that either way, you're going to get 0 for the expected value of x. So moving on to the expected value of x squared, this is actually just going to be 1/3 of the expected value of r squared. Because the whole setup is going to be symmetric, the expected value of x squared is going to be equal to the expected value of y squared, which is going to be equal to the expected value of z squared. And we know that r squared is equal to x squared plus y squared plus z squared. And so we know that the expected value of r squared, which is equal to the expected value of x squared plus y squared plus z squared. And then we can actually break up the expected values. And the reason we can break this up, you can just think of breaking up an integral into two parts. All we're doing is just breaking up an integral into two parts when we are breaking up this expected value sign. So this integral is going to be equal to this integral. If you just think about it, both of these things are the same thing. So that's why we can break up the expected value sign. So you can see that the expected value of r squared is just the sum of these three terms. And you know that both of these are also going to be equal to the expected value of x squared. So all this is just going to be equal to 3 times the expected value of x squared. And so we can just divide this 3 over to the other side. You can see that the expected value of x squared is just 1/3 of the expected value of r squared. And in the last video, we found that this is equal to 3a squared. So in the end, the answer is just a squared. So these are your two answers. This is the expected value of x. This is the expected value of x squared. So this is part B.